Precalculus, 7.5 parametric equations. So parametric equations, we've got kind of a long definition here. So we talk about continuous functions again. And the big important thing here is you can see instead of an ordered pair x comma y, we have f of t comma g of t. So what that's showing is that x is a function of t and y is a function of t. So each of those x and y ordered pairs are defined in terms of t. So instead of like y being 5x, y is going to have something with a t in it, and so is our x. And that's parametric. So basically what parametric is doing is it's giving us this parameter t that we could look at often as time, and it kind of gives us direction to whatever we're looking at for our function and shows us what's happening over time. So t is the parameter, and L is the parameter interval. So parametric equations, the big thing is x and y are both defined in terms of t. So that's really what we're worried about here. So let's see how this works with a math problem. So for example 1, and this is going to be a test problem, we are sketching curves with parametric equations. So we are going to sketch a curve. We're given x in terms of t, we're given y in terms of t, and we're given an interval for our parameter t. So the way we start this out is I make a table. And I have 3 parts to my table. I have a t and an x and a y. I'm going to make my table vertically just because that's how it works here. I don't have a lot of horizontal space, so it doesn't mean they have to be this way. I could make it going across. It's just easier. And it says t is all my values from -3 to 3. So I am going to look at integers. And then I am now going to figure out x. So x is going to be whatever t is squared and then -1. So like for the first one, I'm going to have -3 squared minus 1, which is 9 minus 1. And so I'm going to have 8. I like to do at least a couple where I have kind of some work and I'm thinking it through. -2 squared minus 1. So 4 minus 1 is 3. -1 squared is 1 minus 1. That's going to be a 0. Put 0 in here. I get -1. 1 squared is going to be the same as -1 squared. So I can just repeat those values now. All right, now I'm going to find my y. So for my y, I'm taking t and dividing by 4 and then adding 2. So that means if I start out with -3, I have -3/4 plus 2. So that would be 1 1/4. And then when when t is -2, it's hard, we're used to saying x, but now we have t. -2/4 plus 2, so that's -1/2. So this will be 1 1/2. When I put a -1 in for t, so again, we're plugging in for t, so I'm not even looking at my x's right now. I'm just looking at t and I'm figuring out y. So when I have, let's see, -1/4 plus 2, that's going to be 1 3/4. And when I put in 0, I just have 2. So I can tell that the second one is linear. So the first one I could see symmetrical. I knew that my values would be the same because I was squaring. This one, it's linear, and my slope is 1/4. And I can see that I really am adding 1/4 each time. So I'm just going to fill out the rest of the values using that pattern. So now that I have my values, I'm going to go ahead and graph. And so what we're doing is we're graphing our x's and our y's. Okay, that's not different. We're still graphing x and y. So we're graphing these guys as ordered pairs. And the only thing that's different now is we're also looking at this added, like what's happening over time. So when my x is 8, let's see, where is 8 at? And I'm going to change my scales here. I'm not going to use 5 and 10. I'm going to use, let's see, because I want fourths. 1, 2, 3, 4. This will be 1, 1, 2, 3, 4. This will be 2. And I think that'll bring me right to the top. So this is going to work. So when my x is 8, my y is 1 1/4. And that happens when t equals a -3. When my x is 3, my y is 1 1/2. And this is at t equals -2. And I like to think of t as being time. I know it's a little bit weird to have negative time though, but it doesn't have to be. When my x is 0, my y is 1 3/4. And that's, let's see, t equals -1. And at time equals 0, I have x is -1 and y is 2, and that's at t equals 0. Let's see, when x is 0 again, y is 2 1/4. Let's see, 2 1/4 is right here. Oh, that was 0, not 1. So let's erase that real quick. And let's see, that's t equals 1. And then at t equals 2, I have 3, and then 2 1/2. And then 2 3/4 goes right here. So if you look at this, it's like I have kind of a direction, like it's t equals -3 and then -2. And then, so what that's doing is I don't just have this parabola that's on its side. I also have like a direction, like my graph is going this way. And I don't need all of those t's labeled, but I do need arrows on the graph. The arrows on the graph show me what's happening over time. So it's like a regular XY kind of curve, but that t, that having that parameter, is giving me a direction and it's showing me what's happening over time. So it's kind of a cool, different way to look at stuff. We do have a link in with the notes kind of showing you how these can be used in real life. So you should definitely check that out. So one of the things we care about then is that now that we understand how to graph them, is what if I want to change something so it's not in parametric form? What if I want to have it in rectangular form? Rectangular is normal form where y is a function of x. Where y is a function of x. So what if I want that back? How do I get that? So now that we understand kind of what they are and how they work and how to graph them, what if we want to convert something to parametric? What if we want to convert it out? So in this case, we are given something that's parametric, and I can tell it's parametric because x is given in terms of t and so is y. I don't have just like y equals 5x. How do we get rid of it? So what we're going to do is we're going to start with the one that has x, and we're going to solve for t. So we're going to find the equation, start with the equation that has x, and solve for t. So I'm going to subtract 2. I am going to take a square root. So I have absolute value of t because I had a square and a root, which means I have a plus or minus square root of x minus 2. Oops, in my next step though, not in this step. I'm getting too fast. Plus or minus square root of x minus 2 is going to equal t. So then once I get and solve for t, I'm going to substitute. And I'm going to substitute into the equation for y. So sub for t into the y equation. So now instead of y equals 2t, I have y equals 2 times the positive or negative square root of x minus 2. So I'm seeing on a lot of papers this right now when people multiply, they're writing 2 plus or minus the square root of x minus 2. That's not multiplication. That's adding and subtracting. This shows me 2 is being added or subtracting that root. And that's not what I wanted. I wanted to multiply those two together. So when we multiply, it might help to think of there being a 1 here. And so the 2 is getting multiplied by that 1. And so I actually have plus or minus 2 square roots of x minus 2. So the last thing I noticed on this one is because I have a square root, I want to add in a domain restriction because I cannot square root negatives. And so I need to think about how anytime I have square roots, I need to keep the part that's inside. So that would be the x minus 2 needs to be greater than or equal to 0, which means x is greater than or equal to 2. So I would want to add in that domain restriction to keep from having weird stuff in there. So the last kind of thing we're going to have to do is we're going to have to take something that's rectangular and we're going to have to change it to parametric instead. I'm not going to graph on this one. So we're going to write parametric equations. So on this particular one, I'm giving you a parameter. I'm already telling you how to set t up. So if t equals x minus 1, that means t plus 1 will equal x. And then all I would have to do is substitute this one into the second one for x again. That means y equals the quantity t plus 1 squared plus 2. And then I would want to go through and work that out. T squared plus 2t plus 1 plus 2 is y equals t squared plus 2t plus 3. So then I do need to list them both together. X equals t plus 1 and y equal t squared plus 2t plus 3. So that would be a set of parametric equations. The one that we give you to do on a test or a quiz is going to be a little bit more like this. So I do want to add one more. Let's do 4. I think we would be on 4. I don't even know what number this is. Maybe this is our 4th problem. We'll label it 4. On your test, it's going to be something like write parametric equations. And it's going to be really open-ended. It's going to be something like y equals x squared plus 10. And so because they're leaving this open and they're not telling me what t needs to be equal to, I can let t equal whatever I want. So in this case, I am just going to write that x equals t because that's really easy. And then that would mean my y is just going to equal t squared plus 10. So this could be a set of parametric equations. Or if I wanted to, I could do what I did in the last one. I could say x equals t plus 1. I could say x equals 4t. But whatever I come up with here, then I'm going to have to make sure that I substitute into that second one and work it out. But it is just as easy as writing x is equal to t. So there are unlimited kind of open answers to this, but you just want to make it easy on yourself. It kind of reminds me of decomposing functions. So remember in the last chapter, if we had something like y equals, and I say last chapter, but I think it was chapter 1, if I had like a square root of an x minus 5, and then I had a plus 10, and we looked at that as like f of g of x, and we looked at the part inside, and we kind of broke it apart, you could do the same thing here. You could say that x minus 5 is equal to t, and then you could say y equals the square root of t plus 10. So you could have kind of that same idea about parametric equations. And then, of course, I'd want to solve this one for x. But really, the one that we're giving you is very open-ended. And if you want to make this as easy as just saying x equals t and then changing your letter in your y function, that is fine. So definitely ask about this in class if you're unsure at all. We have some extra practice for these, and you might want to check your answers with us. So please ask questions, work on your 7-5, and don't be afraid to ask for help.